It's 2 a.m. over the Atlantic Ocean. An Air France Airbus A330 is cruising peacefully through the darkness when, without warning, an alarm breaks the silence. The autopilot disconnects. The pilots grab the controls, but within seconds, they're facing something they don't understand. The instruments are showing impossible readings. The aircraft is behaving in ways that make no sense. Then the aircraft begins to fall. Below them lies the deepest part of the Atlantic. The nearest land is hundreds of miles away, and the pilots are running out of time. This is the story of Air France Flight 447. On the evening of May 31st, 2009, passengers began boarding an Air France Airbus A330 at Galeão International Airport in Rio de Janeiro, Brazil. They were bound for Paris Charles de Gaulle Airport, a journey that would take approximately 11 hours and cover nearly 9,000 kilometers across the Atlantic Ocean. The aircraft was a relatively modern Airbus A330-200, just 4 years old at the time. It was equipped with state-of-the-art fly-by-wire technology, meaning that instead of traditional mechanical cables connecting the cockpit controls to the flight surfaces, computers interpreted the pilot's inputs and sent electronic signals to move the aircraft. This system was designed to make flying safer and more efficient, preventing pilots from exceeding the aircraft's structural limits. In the cockpit that night were 3 pilots. The captain was 58-year-old Marc Dubois, a veteran aviator with nearly 11,000 flight hours, over 1,700 of which were on the Airbus A330. He had been with Air France for decades and was known as a competent and experienced commander. Joining him were 2 first officers. The first was 37-year-old David Robert, who had approximately 6,500 flight hours and significant experience on the A330. The second was 32-year-old Pierre-Cédric Bonin, who had around 2,900 flight hours, but was relatively new to long-haul flying. Because of the length of the overnight flight, the crew would rotate rest periods. The plan was for Captain Dubois to take a break in the crew rest area during the middle portion of the flight, leaving the 2 first officers to manage the aircraft. This was standard practice for long-haul operations. Before departure, the crew reviewed the weather conditions along their route. The forecast showed a large area of thunderstorms over the Atlantic Ocean, associated with the Intertropical Convergence Zone. This is a band of weather that circles the Earth near the equator, where trade winds from the northern and southern hemispheres meet. The zone is notorious for producing towering cumulonimbus clouds, severe turbulence, and intense precipitation. Pilots flying across the Atlantic regularly encounter this weather and typically navigate around the worst of it using their onboard radar. At 7:29 p.m. local time, Flight 447 pushed back from the gate. A few minutes later, the aircraft took off into the evening sky and began its climb toward cruising altitude. The initial hours of the flight passed without incident. The aircraft reached its cruising altitude of 35,000 feet and continued northeast toward the African coast. As planned, around 2 hours into the flight, Captain Dubois left the cockpit to take his rest break. First Officer Robert, as the more experienced of the 2 remaining pilots, took the left seat, while First Officer Bonin remained in the right seat. Bonin would be the pilot flying, meaning he was responsible for controlling the aircraft, while Robert monitored the instruments and handled communications. But ahead of them, invisible in the darkness, a massive wall of weather was waiting. By this point, the aircraft was approaching the intertropical convergence zone. The pilots could see the storm system on their weather radar, a massive wall of red and yellow returns, indicating heavy precipitation and turbulence ahead. They requested permission from air traffic control to deviate slightly from their planned route to avoid the worst of the weather. However, in navigating around these storms over the open ocean is not always straightforward. Unlike over land, where pilots can easily divert around weather, the vastness of the Atlantic means that sometimes the only option is to pick the least severe path through the system. The pilots selected what they believed was a gap in the storms and continued toward it. As the aircraft entered the outer edges of the weather system, the outside air temperature dropped significantly. At 35,000 feet, the conditions were ripe for ice crystal formation. The aircraft began encountering light turbulence, and the pilots turned on the seatbelt sign. Then, at approximately 2:10 a.m. UTC, something unexpected happened. The aircraft's pitot tubes, which are small sensors mounted on the exterior of the fuselage, that measure airspeed by capturing incoming air pressure, began to ice over. Despite being equipped with heating elements designed to prevent this, the combination of high-altitude, supercooled water droplets and ice crystals overwhelmed the system. Within seconds, the airspeed indications in the cockpit became erratic. The autopilot, receiving conflicting and unreliable data, did exactly what it was programmed to do. It disconnected. An alarm sounded in the cockpit. The autopilot disconnect warning chimed repeatedly as the flight computers simultaneously downgraded from normal law to alternate law, meaning several of the aircraft's automated protections were now disabled. The pilots were suddenly faced with flying the aircraft manually in the middle of the night in turbulent conditions with instruments they could no longer trust. And in that moment of confusion, First Officer Bonin made a critical mistake. Startled by the sudden disconnection, Bonin grabbed his side stick. His instinct was to pull back. In most emergency situations, climbing away from danger is the correct response. Pilots are trained to gain altitude when something goes wrong, because altitude means time and options. But in this situation, pulling back was exactly the wrong thing to do. Under normal circumstances, pulling back on the side stick causes the aircraft's nose to rise. This is exactly what happened. The Airbus A330 began to pitch up, and its altitude started increasing. At the same time, the airspeed continued to fluctuate wildly on the instruments. First Officer Robert recognized that something was wrong. He called out that they had lost the airspeed indications and told Bonin to watch his speed. But in the confusion of the moment, with multiple alarms sounding and the aircraft buffeting in turbulence, the message didn't get through clearly enough. Bonin continued pulling back on the side stick. The aircraft climbed rapidly, going from 35,000 feet to over 37,000 feet in just two minutes. But as the aircraft climbed, it was also slowing down dramatically. The angle of attack, which is the angle between the wing and the oncoming air, was increasing beyond safe limits. Then came the sound that should have told the pilots everything they needed to know. The stall warning activated. A computerized voice called out repeatedly as the aircraft's wings approached the point where they could no longer generate enough lift to sustain flight. But here is where a critical confusion occurred in the Airbus system. When airspeed data becomes unreliable at very low speeds, the stall warning can actually stop sounding because the computers believe the data must be erroneous. This meant that as Bonin pulled back and the aircraft slowed further, the stall warning would intermittently stop and start, creating a confusing pattern of alerts. When the pilots did the right thing and lowered the nose, the warning would suddenly blare. When they pulled back and made things worse, it would stop. The system was essentially giving them backwards feedback. The aircraft was now fully stalled. Despite the nose being pointed upward, it was no longer flying. It was falling. At 2:11 a.m., with the situation spiraling out of control, First Officer Robert made an urgent call to the captain's rest area. Captain Dubois returned to the cockpit within a minute, but the scene he walked into was one of complete chaos. Alarms were blaring. The aircraft was shaking violently, and his two first officers were struggling to understand what was happening. The captain asked what was going on. The response from his crew was fragmented and confused. Nobody could clearly articulate the problem because nobody fully understood it. The basic reality that the aircraft was in a stall and falling from the sky was not recognized by anyone in the cockpit. Throughout this crisis, First Officer Bonin maintained his back pressure on the side stick. The aircraft remained in a nose-high attitude while plummeting toward the ocean at a vertical speed of over 10,000 feet per minute. The stall warning continued sounding, yet the crew never executed the standard stall recovery procedure, which would have required pushing the nose down to regain airspeed and restore lift. At one point, First Officer Robert attempted to take control and push the nose down. But on the Airbus, when both pilots move their side sticks simultaneously, the inputs are combined unless one pilot presses a priority button. Unlike traditional control columns that move together and allow each pilot to feel what the other is doing, the Airbus side sticks operate independently. Neither pilot took priority, and Bonin's continued back pressure essentially canceled out Robert's corrective inputs. Robert had no way of knowing that Bonin was still pulling back. The crew remained unaware that the aircraft was in a sustained stall. They focused on the airspeed problems, the multiple system warnings, and the confusing flight data. The fundamental aerodynamic reality of their situation, that the wings had stopped flying, never clicked into place. For 3.5 minutes, the Airbus A330 fell through the night sky. 38,000 feet, 30,000 feet, 20,000 feet. The altimeter unwound with terrifying speed. Inside the cabin, passengers who had been awakened by the turbulence experienced a nightmare they could not understand. The aircraft was pitching and rolling. The engines were roaring at high power, and yet they were falling. 10,000 feet, 5,000 feet. At 2:14 a.m. UTC, just seconds before impact, the ground proximity warning system activated. A synthetic voice announced the final warning as the aircraft plunged into the Atlantic Ocean at a vertical speed of nearly 11,000 feet per minute. The impact was catastrophic. The aircraft disintegrated on contact with the water. All 228 people on board, 216 passengers, and 12 crew members were killed instantly. But what exactly had gone wrong in that cockpit would remain a mystery for nearly 2 years. When Flight 447 failed to arrive in Paris the next morning, a massive search operation was launched. Brazilian and French military aircraft scoured the Atlantic along the aircraft's planned route. Within days, searchers located debris floating on the surface, along with the bodies of some of the victims. But the ocean in this region is extraordinarily deep, reaching depths of over 13,000 feet in some areas. Finding the flight recorders would be essential to understanding what had happened. Without them, investigators would have only fragments of data transmitted by the aircraft's automated reporting system before the crash. But locating two small orange boxes in an area of ocean covering thousands of square miles and reaching depths greater than the height of most mountains seemed nearly impossible. The initial search for the recorders failed. Submarines and sonar-equipped ships scanned the seabed but found nothing. Months passed, then a year. The investigation continued with the limited data available, but the exact cause of the crash remained unknown. Finally, in April 2011, nearly 2 years after the crash, a new search effort using advanced autonomous underwater vehicles located the wreckage on the ocean floor. The flight data recorder and cockpit voice recorder were recovered from a depth of nearly 13,000 feet. The recorders revealed what had happened. The pitot tubes had iced over, causing the loss of reliable airspeed data. The autopilot had disconnected as designed. But the critical factor was what happened next. The investigation by the French Bureau of Inquiry and Analysis determined that when faced with an unexpected situation, the pilot flying had reacted with sustained nose-up inputs that led the aircraft into a stall. Despite the stall warning sounding continuously for over 50 seconds during the descent, the crew never recognized that they were stalled and never applied the correct recovery procedure. The report pointed to inadequate training for high-altitude stall recognition and recovery. It also highlighted issues with how the aircraft's systems presented information during the crisis, contributing to the crew's confusion. The design of the Airbus side-stick system, where one pilot cannot feel what inputs the other is making, was also identified as a contributing factor. In the case of Flight 447, First Officer Roberts' attempts to push the nose down were being canceled out by Bonin's continuous back pressure, and neither pilot was aware of what the other was doing. The pitot tubes that iced over that night were a model known as Thales AA. In the 2 years prior to the accident, Air France had recorded multiple incidents of unreliable airspeed indications involving this same model. A replacement program had been initiated, but at the time of the crash, Flight 447's pitot tubes had not yet been changed.